Let's do this. All right. It is 2.4, and I'm sure the learning target's right above this video inside the teaching lesson, but it is today I will solve equations with variables on both sides of the equal sign. So let's go and get real up in this hizzy. But before that, here's your warm-up. Take a minute and do it. As always, whenever I tell you to do something, I'm going to assume you're pausing me, and so I'm going to continue very quickly after that. It's not because I'm rushing you, it's just because I'm assuming you're pausing it. So, ready, set, go. And I assumed you were I was paused there. All right, let's talk about this warm-up. All right. So if x equals 2, what we're doing is substitution. Just sub it out there. It's going to be amazing. We're going to have 3 times negative 2. I'm getting better at this mouse writing, minus 5. It helps that I did go out and buy a wireless mouse, so I don't have to use my finger paint skills. Okay. What's positive times negative? It's negative. This is going to be 3 times negative 2 is negative 6. Negative 6 minus 5, party or war? It's a party because they match, and it's a negative party, so we're going to add them together. We know it's going to be a negative party. 6 plus 5 is 11. Boom, right there. All right, let's try it here. We have negative 2 over 2 plus 3. All right, now, this negative is touching technically that negative, so that makes it positive. So I'm going to have 2 divided by 2 is 1, and 1 plus 3 is 4. This one, we have negative 5 times negative 2 squared plus 1. Now, keep this in mind, because that negative 2 is inside the parentheses, right, because we substituted it in for x, that negative is also being squared. So the negative 2 squared is actually positive 4. Negative 5 times positive 4 is going to get me negative 20. And then plus 1. It's a war. How much does the negative 20 win by? It wins by negative 19. 19. There we go. And then last but not least, we have 4 minus 8 and x cubed, so negative 2 cubed. Now, negative 2 times negative 2 is positive 4, but times negative 2 again is negative 8. So we're going to end up with, over here is going to be negative 8 times negative 8, which is going to get us 4 plus 64, because the negative times the negative is a positive, right? Which equals 68. Boom. Jessica has P ponytail holders, and she gives 3 of them to her best friend, so we're going to have P minus 3, right? Write an expression for the situation, then evaluate if P equals 15. Well, she has P ponytail holders, and she gives 3 of them to her best friend. Yeah, it's just P minus 3. So it's going to be 15 minus 3, which means 12. So we're going to say just has, remember, a word question gets a word to answer. Just has 12 holders left. Normally I'd say ponytail holders, but I'm spelling with my mouse. So not as awesome. Just throwing that out there. Okay, all right. Remember to pause this if you need to write anything down. Make sure you have warm-ups in your notes. Let's get into this lesson. I'm excited, folks. I'm excited. So we're going to launch it with this question right here, and it says, can I zoom that in? Is that possible? Is that a thing? Oh, wait, there's a magnifying glass. No, that's a search. I thought that was a zoom. Oh, well. Bailey works at a grocery store each month. She deposits part of her paycheck into her savings account and the rest into her checkings account. Right now, Bailey has $1,500 in her savings account. She deposits another $80 each month. So, what are we starting with? Ooh, I gotta put my thing. We're starting with 1,500. I know I haven't finished reading it, but I like to write down stuff as I go. And we're doing 80 per month. she has $120. She has $120 in her checkings account and deposits another $425. Oh, so this is savings. We're going to have checking, where she has $120 and deposits $425 each month. In how many months will the amount in the two accounts be the same? Okay. So we got two expressions we can write here. Right here I can write, first of all, let's identify this. We're trying to identify months. So I'm going to let the variable m be months, okay? Then we're going to identify our variables. So we're trying to find out how many months. Well, the unknown is months, okay? I know in our savings account, I have $1,500 to start off with, and I'm adding in $80 because I deposit. It means I'm adding in $80 each month. So I was going to put X, but times M. And I know that because, right, if it's 10 months, 10 times 8, right, that'd be 10 80s, which would be $800. If it's 5 months, that'd be 5 80s, which is $400, right? So it's just, this tells me how much money I have in each month, okay? And we want to know when that's going to equal. We'll see in the checkings account, she only has $120, and she's adding in $425 each month. All right, this is a pretty simplistic problem because we're acting as if she's not spending anything at it either. So we're going to ignore that part of it. But right now, we want to solve this problem right here. Take a moment, pause it, see what you can do. Ready, set, go. All right. So again, the same rules I went over yesterday still apply, right? What you do to one side, you do to the other. But what was rule number one? Rule number one was get the variables on one side, get the numbers on the other. So I'm going to choose, let's see, I'm going to choose to put the variables on the right side because this is a bigger number, and that way I'm not going to have negatives. All right, so I'm going to subtract 80 from both sides. Subtract 80, M. I'm going to minus, oh, that is a bad place to put it. Undo, minus 80, M, right? Okay. Not only am I going to do that, guys, well, let me do this in one step. I think it might help if I do it in one step. And I've got to kind of erase up here, so make sure you have this part in your notes, but I've got to erase it for the interest of room. Whiteboard, just wiping it off. And I'm going to get 1,500 equals 120 plus, let's see, when I took away 80, that became 345 M. Now, I still am on that step because I've got the variables on the right, but I need to get the numbers on the left. So I'm going to subtract 120 from both sides. Now, could I have done this in one step? Like, could I have gone down here and just been like minus 120, minus 120? Absolutely. And if you're okay doing that, feel free. I just wanted to show this step by step for all involved, right? Equal sign separates sides. 1,500 minus 120 is going to be 1,380. So now I have 1,380 equals 345. That should be 80. 345. I'm looking over here using my handy dandy calculator, which you should too. Or you don't have to, but it's 345 M. Now what's rule number two? It says to get the variable by itself. So now I just want to get M by itself. What's been done to M? It's being multiplied by 345. How do we undo multiplication by 345? We divide by 345, right? And there seems to be some confusion about divide by what? Whatever number is next to the variable. That's what we want to get rid of. We're dividing by that because a number divided by itself is 1. So now that's gone. What I do to one side, I got to do to the other. Divided by 345. And let me see on my calculator, 1380 divided by 345 equals, what do you know? Actually comes out nice. We get that m equals 4. Now, I'm not going to type the sentence out. I'm going to let you guys do it. But you need to have a sentence answer to this. So the answer I would use is Bailey's accounts will have the same amount after 4 months. That's what that tells us. So we're able to actually use this to identify and solve a fairly complex problem. Good job. All right, let's move on to the next one. Okay. So we're talking about modeling an equation. Let me go ahead and move some stuff out of the way here. It says you can sketch and explore an equation with a variable on each side and then complete the exercise. Percy and Quincy are racing. At this point in the race, Percy is behind Quincy, but he moves 5 spaces every time he jumps, and Quincy moves 2. You can use the sketch to find the number of jumps X it takes for Percy to catch Quincy. So, Percy's jumping 5 spaces every time Quincy jumps 2. Or is it jumps? No, he moves 2. Okay? So I'm going to hit this jump button. I guess I should probably be up here. Move! Alright, jump. Look at that. One jump. He's getting closer. He's getting closer. Oh, he's almost there. I think the next one's going to do it. And it took 4 jumps. And notice at 4 jumps, both their values on the number line are the same. So this is an equation, right? We can reset it. Isn't that cool? Oh, look. Let's do it fast. You ready? Go, Percy! Go, Percy! Percy goes! And then Percy wins. All right. So it's pretty neat there how it works. And I want to talk about this. All right. Here's some questions. Write an expression that gives Percy's position after X jumps. Well, where's Percy starting off from? Percy's supposed to be starting off from 0. That's weird. Let's see if it works. Doesn't feel like 0. Oh, it's not. Okay, so he's starting off, if here's 0, Percy's starting off at -1, 2, 3, okay? And Quincy's at 9. There we go. I was looking at the wrong thing. I was saying, something's off there. Okay. So, first of all, we know that Percy is starting at -3, but he's jumping 5 spaces each jump. We don't know what the number of jumps are. So if I were filling this in, I would say, all right, he's starting off at -3. I think that's what it was, yeah. -1, 2, 3, yeah, sorry. It's early in the morning, I forget things. But what's he adding every jump? He's adding 5 spaces. Now, we got to remember, we're going to let let's let J be the number of jumps. So we're talking about Percy right here. And Percy goes 5 spaces every jump, so we've got to have J there. And then I want to also write another equation for Quincy. Quincy is starting off at 9. But what's he adding each time? He's only moving 2 spaces for every jump. So eventually Percy's going to catch up. All right? And it says, at the moment when Percy catches Quincy, let me move these out of the way a little bit. The position of the 2 rabbits are the same. Use the expression you wrote to write an equation for when the rabbits are in the same position. Well, what we do is we just set these equal to each other. When they equal each other, we know they're at the same exact position. So I would write 3 plus, I like to put spaces in between, 5J equals 9 plus 2J. And I'm typing this in because I think it's a little easier to see when we're typing it. But keep that in mind. we're setting them equal to each other. And then we just simply solve that, which I believe it's going to ask us to do. You can find the moment when Percy catches Quincy by solving the equation that you wrote. How is this equation different than the other equations you solved before? Well, first of all, it's different because there's variables on both sides, so it adds that extra step of we've got to, where rule number one is get variables on one side, numbers on the other. Well, yesterday, all the variables were always on either the left or right. Today, we have to account for that. So this one I am going to draw it. I'm just going to use it up here. If I solve for it, again, so I'm going to go ahead and how do I move a positive 2j? Well, I subtract it. So I'm going to subtract 2j from both sides. Minus 2j. And what do I end up with? I end up with 3 plus 3j equals 9. Right? Because that's gone now. And then, again, I want to get the numbers on the same side. So I got to get rid of this positive 3. How do I move a positive 3? I subtract it. When I do to one side, I do to the other. And I end up with 3j equals 6. Ooh, I forgot something, guys. I realized what happened here. I'm going to back up just a little bit. Here, I'll make this easy. I just realized something. This part was all good, but that should have been a negative 3j. Did I mess that up top? I don't know if I did, but this should be a negative 3, right? Because Quincy started off at negative 3, not positive 3. I don't know what happened in my brain there. I told you if I make mistakes, I'm going to leave it in because you got to see what happens if I make mistakes and how we correct it. I just go, hey, something didn't make sense there because I was going to get an answer of 2. 2 didn't work because it took more than 2 jumps. So, all right, negative 3. All that does is, so I'm going to have negative 3 plus 3j. Guess I didn't have to erase quite so much equals 9. Instead of subtracting 3, now I'm going to add 3. All right, this is going to get me more of a result that makes sense. That crosses out. 3j equals 12. All right, there we go. Now we're cooking with peanut oil. How do we undo multiplication? We divide both sides by 3, and we get that j equals 4. It's going to take 4 jumps. And we saw that, didn't we? Because up top, when we did it, 1 jump, 2 jump, 3 jump, 4 jump. Look at that. They're at the same spot. So we see that work out. And then the last, what term do you need to eliminate from the right side? Oh, we already did that by just solving through it, so I'm not worried about that. Okay, so that's solving the Percy problem. Let's go ahead and move on to the next slide. We're going to get some more practice with this. All right, so just looking right here, I'm going to work this out with you. So again, we want to solve for A, and then it says to check our solution. So we're going to talk about how to do that at the end. So the first thing I'm going to do is get variables on one side, get numbers on the other. So I'm going to, I want to move the 4A to the left. By the way, take a minute, pause this, try it on your own. Ready, set, go. All right, we're back. So I'm going to subtract 4A from both sides, minus 4A. Remember, the sides are separated by the equal sign, right? And I end up with 5. Nothing didn't do anything to that. 7A minus 4A is positive 3A, so plus 3A equals, those 4's canceled out, minus 13. Now I need to move the numbers to the same side, so I'm going to take this 5 and move it. A positive 5 we move with a minus 5, minus 5. And I get 3A, boom, equals negative 18. Got to remember my negatives, right? And how do we undo multiplication? Well, we divide. And what am I multiplying? I'm multiplying by 3, so I'm going to divide both sides by 3. Divide by 3. What's a negative divided by a positive? It is a negative. So negative 18 divided by positive 3 is going to be negative 6. A equals negative 6. Now it says to check it. Remember, we're going to check our answers sometimes. It says check it. We got to check it. I'll just check it in blue. And check your colon there. All right. I'm going to have 5 plus 7, and instead of a, I'm going to put negative 6 equals 4 times negative 6 minus 13. And we're going to see if these two sides of the equation come out the same. So PEMDAS tells us to do multiplication first. We're doing left and then right. So I'm going to have 5. What just happened? Like my button got stuck down. So we're going to have 5, and a positive 7 times negative 6 is going to be negative 42 equals, now let's do the left side. 4 times negative 6 is negative 24. And that should be minus 13. Don't know what happened to my 3, but there we go. So minus 13. What's 5 minus 42? Well, that's a war for sure, right? Positive and negative. And the 42 is going to win by, looks like negative 37. So that's going to be negative 37. And let's see if it equals, what's negative 24 minus 13? Guess what? That's negative 37. Is that a true statement? Yes, negative 37 equals negative 37. Check. It worked. So that is how to solve it and check it. Again, pause this if you need to write it down. We're heading on. All right, this is all you guys. Take a moment, solve this, ready, set, go. Okay, my turn. Let's see what happens. Are you ready for this? So I'm just going to write right over there. I'm going to add my 13c to the right, just so I make my c's positive. I like to keep my variables positive if I can. You don't have to. It'll solve fine. But that's why I'm moving it to the right. Some people get uncomfortable putting variables on the right because we're just used to it on the left, so that's up to you. So I'm going to do that. I'm going to end up with 5 equals, and what's 4c plus 13c? That's 17c plus 39. Now I'm going to get my numbers on the left, so minus 39, right, because that's the opposite of plus. Minus 39 is going to get me negative 34 equals 17c. And now I need to get the variable by itself. So I'm going to divide by 17 to undo that multiplication by 17. Divide by 17, divide by 17. Negative 34 divided by positive 17 means that c equals negative 2. Then it says to check it, so you know we're going to check it. Let's check it in red this time. Colon. Awesome. I'm going to have 5 minus 13 times negative 2 equals 4 times negative 2 plus 39. All right, what's negative 13 times negative 2? Well, that's positive 26, so I'm going to have 5 plus 26 equals 4 times negative 2 is negative 8 plus 39. And 5 plus 26 is 31 equals negative 8. So 39 minus 8 is 31. Look at that. Check. Boom. We're done. Crushing this. Write it down. Make sure you have all this. Hopefully you're getting to it. It's amazing. All right. This is our last thing of the day, so let's take a minute, look at it, see what we can accomplish. I gotta move this down so we see a little better. The National Hot Dog Eating Contest is a competition that takes place every year at New York's Coney Island on July 4th. The results of the 2015 National Hot Dog Eating Contest are shown below. Check this out, though. Watch this. Watch this. It's crazy how much they eat. They're like skinny people. You'd think it'd be fat people, but it's like skinny people, just like, oh. I watched one of these once. I thought I was going to toss my cookies. I just couldn't keep watching. But look at her. She was shoving down. Look at all of them. It's crazy. And look at the scoreboard. For the men, Matt Stoney ate 62, and Mickey Sudo for the women ate 38 hot dogs. Oh, my stomach hurts. Well, they have eaten the same number of hot dogs. Okay? So we're going to follow this down. Are you ready? Matt eats how many hot dogs in 10 minutes? Well, he eats 62. And that includes buns. Oh, that's crazy. So he eats 62. Gotta get my numlock off. Which is a rate of, well, 62 divided by 10, that's 6.2 hot dogs per minute. The number of hot dogs he's eaten in minutes after starting is, well, that would be 6.2 M. Mika eats how many? 38 hot dogs in 10 minutes. 38 hot dogs in 10 minutes, which is a rate of, if you divide that by 10, 3.8. It's just moving the decimal point over, right? Let me move all this stuff up. She is given a 20 hot dog head start, so the number of hot dogs she has eaten after Matt starts is 3.8 M plus, well, it's plus 20. Boom. So the equation is going to be 6.2 M equals 3.8 M plus 20. Awesome. And going down, it shows us how to solve that. Watch. They're just going to subtract 3.8 M from both sides. They get 2.4 M equals 20. And when we divide by 2.4, we get that roughly 8.3 minutes after starting, or 8 1/3 minutes. So that's how we would solve a problem such as this. It's been an interesting lesson. What a way to end on a hot dog eating contest. So with that said, you guys are amazing. We'll talk more about it tomorrow. Peace out.